All right, welcome back. Hopefully, we can finish the worksheet today. Question number 11. Switch to the friction tab at the top of the page. Turn the friction on using the button on the right of the right side of the page. What is the difference in the skater's motion with friction compared to without friction? What that's asking you to do is to go over here on the right side, turn on the friction, make sure that your graph is on and that your grid is on. With lots of friction, you should notice a big difference in either potential or kinetic energy or both. Yeah, you're wanting to make sure you had a lot of friction and see what happens. Look at the graph and take note of what's going on. Question number 12. Compare how small friction affects the motion um, of the skater to how large amounts of friction affects his motion. You're comparing both small friction to motion and how large amount of friction compares to motion. So make sure your answer includes how friction helps or slows down or speeds up motion. Now in 13, you're going to have to change your track and turn off friction. So to do that, they want you to go to Playground tab, and they want you to make sure that friction's off or down. Now in this one, you build your own track, whatever you want, does not matter as long as your skater can ride it. It does not have to look like this, look like anything you want. So you build your own track. All right, this one it won't work very well. You'll make a better one, I know it. When you make your own track, make sure that you draw it in this space below. So it should look something like yours that you made right here. All right. After you have drawn your track, make sure you label the point or points where you have high kinetic energy and where you have low kinetic energy. So if it's a high kinetic energy zone, you write KH. When it's a low kinetic energy, you write KL. Same thing with potential energy, high potential, low potential. And then think about how you could change your track to maximize the kinetic energy. So, what would you do after you've made your track? What would you do to make it a faster or better track? Also, how could you change your track so the skater's kinetic energy stays low? So what would you do to make sure you have a very slow um, track? Post lab. Describe a baseball in a game when a player has a lot of kinetic energy. When would the baseball game, when would a player have a lot of kinetic energy? Make sure you're explaining your answer why. Number two, describe a situation in a baseball game when a player has lots of potential energy. Explain your answer. So one and two are similar, but one's looking at the kinetic energy or moving energy, and the baseball game when the player has potential energy. Number three, based on what you observe in the simulation, what factors affect kinetic energy? Make sure you write more than one because it's asking for factors. Based on what you observed in your simulation, what are the factors that affect potential energy? Number five, based on what you've read in the pre-lab reading, why does mechanical energy of the skater not change over time unless there's friction turned on? So look back in the pre-reading at the beginning, and that should help you with question number five. Reread the law of conservation of energy in the pre-lab section. You need to go back all the way up to the top. That's mechanical energy. And the second or fourth one is the law of conservation of energy. What do you think happens to the skater when friction is involved? Look at questions 11 and 12. An archer stands on the ground and fires an arrow at a target. A second archer stands on the top of a building and holds the arrow in his hand. Which arrow has more potential energy? You have an archer standing on the ground who's going to fire the arrow, and a second archer standing on the top of a building holding an arrow in his hand. Which one has more potential energy? As long as you're explaining this one, it's not a very great question, but as long as you're explaining your thinking, I think that's more important. Number 8, in the same scenario described in question 7, which arrow has more kinetic energy? When you're finished, make sure that you check back over your answers, that all answers are complete, and then turn it into the front.